There is a moment in every major defense program when the paperwork stops mattering and the politics take over. For Europe's attempt to build a sixth-generation fighter, that moment arrived in June 2026, when Germany effectively walked away from the crude fighter at the heart of the Future Combat Air System, or FCAS. The timing could hardly have been more dramatic. The announcement came at the ILA Berlin Air Show, the same event where Germany and France had unveiled the FCAS vision 8 years earlier. A project that had once been presented as a symbol of European unity was now losing the aircraft that was supposed to become the centerpiece of Europe's future air power. But while FCAS was breaking apart, another sixth-generation program was moving in a very different direction. The Global Combat Air Program, or GCAP, led by Britain, Italy, and Japan, was continuing development of its future fighter, while Rolls-Royce, Italy's Avio Aero, and Japan's IHI Corporation were pushing their next-generation propulsion system toward ground testing. And that creates the central question of this story. Did Germany's withdrawal from FCAS just kill Europe's biggest fighter project, or did it unintentionally clear the way for GCAP to become the continent's leading sixth-generation aircraft program? And if GCAP succeeds, could that eventually create a strategic problem for the United States and the Pentagon? To understand that, we have to go back to the beginning. France and Germany announced their future combat air partnership in 2017 under Emmanuel Macron and Angela Merkel. Spain later joined, and the project was formally unveiled at ILA Berlin in 2018. The ambition was enormous. FCAS was supposed to replace France's Rafale and the Eurofighter Typhoon with a new generation of combat aircraft beginning around the 2040s. But this was never intended to be simply another fighter. The centerpiece was the new generation fighter, a crude stealth aircraft. Around it would operate unmanned remote carriers. And connecting everything would be a digital combat cloud. The idea was to create a system in which fighters, drones, sensors, and weapons could share information almost continuously. A fighter could detect a target, another aircraft could engage it, an unmanned system could move into a dangerous area, artificial intelligence could help process the information. The aircraft itself would become one node in a much larger combat network. That concept remains extremely important because it is also shaping America's F-47 and Britain's GCAP. The problem was not the basic idea, the problem was politics. From the beginning, the biggest argument inside FCAS was over who would control the fighter. On the French side was Dassault Aviation, the company behind generations of French combat aircraft from the Mirage family to the Rafale. Dassault wanted strong control over the fighter's architecture and design authority. On the German and Spanish side was Airbus Defence and Space. Airbus wanted genuine co-leadership, significant industrial workshare, and technology access for German and Spanish industry. This was not a minor disagreement. It was a fight over who would control Europe's most advanced future combat aircraft. Who would make the key design decisions? Who would own critical intellectual property? Who would control upgrades? And which country's aerospace industry would receive the most valuable engineering work? The disagreements dragged on for years. The demonstrator phase was delayed. Political patience began to disappear. And by 2026, Germany was no longer willing to continue indefinitely without a settlement. Mediation was attempted, but the industrial dispute could not be resolved. By June, the decision had effectively been made. Germany and France abandoned the original plan for their jointly developed crude sixth-generation fighter, and then came the symbolism. Germany announced the decision at the same air show where the program had been unveiled 8 years earlier. The FCAS fighter was effectively finished before a prototype ever flew. That distinction is important. FCAS as a broader technology effort did not simply vanish. The combat cloud concept still has value. Autonomous and remote systems remain relevant. Some elements of the wider system of systems architecture can continue, but the central aircraft, the sixth-generation fighter that was supposed to replace the Rafale and Eurofighter, is no longer being developed under the original Franco-German arrangement. And that leaves Germany with a serious strategic problem. Germany still needs future combat aircraft. The F-35 will provide an important fifth-generation capability. The Eurofighter will continue serving for years, but eventually Germany needs to decide what comes after them. And suddenly the answer looks much less obvious. One possibility is a new national or European arrangement involving Airbus. Another is deeper cooperation with Sweden's Saab. Another is greater reliance on American aircraft. And then there is GCAP. The Global Combat Air Program brings together the United Kingdom, Italy, and Japan. Its objective is to develop a sixth-generation combat aircraft for around the mid-2030s. The program is built around the Tempest concept and is intended to combine advanced stealth, sensors, electronic warfare, networking, artificial intelligence, and autonomous systems. In other words, GCAP is pursuing many of the same broad battlefield ideas that FCAS was designed around, but the industrial story is different. GCAP has managed to keep Britain, Italy, and Japan inside one program, and in 2026, it is increasingly producing evidence that the program is moving from concepts toward hardware. The most important example is the engine. Rolls-Royce is working with Avio Aero and IHI Corporation on the GCAP power and propulsion system. This is not simply about producing thrust. A sixth-generation fighter is expected to require huge amounts of electrical power for radar, electronic warfare, computing, sensors, and future weapons. All of those systems also generate heat. So the engine has to become part of the aircraft's electrical and thermal architecture. It has to provide propulsion while helping support the aircraft's electronic systems. That makes the GCAP engine one of the most technologically important pieces of the entire program. And in July 2026, the Propulsion Consortium announced another significant milestone. Rolls-Royce, Avio Aero and IHI said they had completed a series of consortium design reviews and moved closer to ground testing the GCAP engine demonstrator. More than 100 component tests have been completed as the partners prepare for the next phase. That is real engineering progress. But there is an important correction to some of the more dramatic headlines surrounding the story. The GCAP engine has not yet been publicly demonstrated as a complete integrated engine running continuously on a test stand. The current milestone is preparation for that stage. The next major test will be much more demanding. Engineers will have to prove that the components work together. They will measure temperatures, pressures, vibration, electrical output, and thermal performance. They will test the control system. They will examine how the engine behaves under sustained loads. And eventually they will have to demonstrate that the entire propulsion architecture can support the aircraft it is supposed to power. That is why the engine milestone matters. A design review is important, a component test is important, but an integrated engine running under representative conditions is a different level of evidence. And GCAP is now moving toward that point. The consortium has also invested in a dedicated collaboration hub in Reading, bringing partner organizations closer together and supporting the wider GCAP development effort. That may sound like a small administrative detail. It isn't. Large multinational defense programs frequently fail because coordination becomes too complicated. Different countries have different priorities. Different companies protect different technologies. Different governments want different industrial benefits. Creating permanent structures for cooperation is therefore part of the engineering challenge. And GCAP is trying to solve that challenge while simultaneously building the aircraft. This is where the contrast with FCAS becomes striking. FCAS spent years fighting over industrial leadership. GCAP is attempting to turn its multinational structure into an advantage. But GCAP has its own problems. The program is expensive, its schedule is ambitious, Japan has expressed concerns about pace, Britain faces broader defense budget pressures, and adding Germany would not automatically be simple. There is currently no confirmed German full membership in GCAP. If Berlin eventually wants to join, Britain, Italy, and Japan would have to agree on the terms. Germany would want industrial work. It would want influence. It would want technology access. And the existing partners would have to decide how much of their own work share they were willing to give up. Ironically, those are exactly the kinds of questions that contributed to FCAS's collapse. So Germany cannot simply move from one program to the other without political complications. But the collapse of FCAS has nevertheless changed the European landscape. Before 2026, Europe had two major sixth-generation fighter efforts, FCAS in the west, GCAP in the east. Now the situation is very different. FCAS no longer has its original crewed fighter. GCAP is therefore becoming the most visible European-led program still moving toward a sixth-generation aircraft. And that matters to the United States. The Pentagon is developing its own sixth-generation fighter, the F-47. Boeing was selected to build it as the crewed centerpiece of the U.S. Air Force's next-generation air dominance program. Like GCAP, the F-47 is expected to operate alongside autonomous collaborative combat aircraft. So America understands the same basic transformation taking place in Europe. The future fighter is not going to operate alone. It will be connected to drones, sensors, weapons, and other platforms. The difference is that the United States has enormous resources behind the effort. America has decades of experience developing stealth aircraft. It has advanced sensors, it has mature combat networks, and it already has an enormous international ecosystem built around the F-35. That gives Washington a major advantage, but there is a weakness. The F-47 is primarily designed around American requirements, and America's history with exporting its most advanced fighter technology is complicated. The F-22 is the obvious example. The Raptor was never exported, not to Japan, not to Britain, not to Australia, not to any other U.S. ally. That decision protected highly sensitive technology, but it also meant that America's allies eventually had to look elsewhere for their next-generation fighter needs. The F-35 solved that problem in a very different way. It was designed from the beginning as an international program. Partner countries participated in development and production. Foreign customers bought large numbers, and the result was an enormous international ecosystem. But the F-47 may not necessarily follow that model. If its most advanced capabilities remain tightly restricted, potential customers could face a difficult choice. Do they buy a less capable export configuration? Do they wait? Or do they develop or join an alternative program? That is where GCAP becomes strategically interesting. GCAP is not simply an aircraft being built for 3 countries. It is a multinational industrial program. Britain has a stake, Italy has a stake, Japan has a stake. Their companies are involved, their governments are involved, their industrial bases are involved. And that creates something the United States may not be able to replicate easily with a highly sensitive American-only fighter. It creates industrial sovereignty. For countries that want to remain close to Washington but also maintain control over their own defense industries, that could become extremely attractive. Germany is the obvious example. Berlin's entire FCAS dispute was partly about industrial sovereignty. Germany did not want to spend enormous amounts of money on a fighter while remaining dependent on another country's design authority. That does not mean Germany will join GCAP, but it explains why GCAP is suddenly attracting so much attention. Leonardo has publicly discussed the possibility of German participation, and the broader European defense industry is already examining what comes next after FCAS. Reuters reported in July that the collapse had also created uncertainty for the Franco-German engine partnership involving MTU and Safran, with differences emerging between French and German requirements for their future aircraft. That is another important consequence. FCAS did not just lose a fighter, it disrupted an entire industrial ecosystem: engine development, airframe design, sensors, manufacturing, supply chains, and thousands of jobs tied to a future aircraft. The collapse therefore forces Europe to answer a much bigger question. Can Europe actually maintain independent 6th-generation fighter development without splitting into competing national programs? That question matters because the United States is not the only competitor. China is also developing next-generation combat aircraft. By 2026, Chinese 6th-generation prototypes associated with programs such as the J-36 and J-50 had attracted significant attention. That means the global race is no longer theoretical. The United States is developing the F-47, China is flight testing advanced next-generation designs, GCAP is moving through development, and France is now considering what its own post-Rafale future should look like. The world is entering a period where several major powers are attempting to leap beyond 5th-generation fighters at the same time, and the technology is changing. Stealth remains important, but it is no longer enough. The next-generation aircraft will depend on sensors, data, artificial intelligence, electronic warfare, autonomous systems, long-range weapons, and enormous amounts of electrical power. That is why the engine is so important. The engine is becoming an energy system for the entire aircraft, and that is why the Rolls-Royce, Avio Aero and IHI partnership is being watched so closely. If the Demonstrator eventually runs successfully, it will provide evidence that the program's advanced propulsion architecture can actually work. If problems appear, that is also valuable, because engineers can identify them before the operational engine is designed. Either way, the test stand becomes a critical milestone. And there is another important point. GCAP is not waiting for the final fighter to begin reducing risk. Britain is separately developing a flying combat air demonstrator intended to test technologies, manufacturing methods, and systems relevant to the future program. That kind of risk reduction is extremely important, because the biggest danger facing a 6th-generation fighter is not necessarily that the technology is impossible. The danger is that too many technologies become impossible to integrate at the same time. Stealth, engines, weapons, sensors, artificial intelligence, autonomy, communications, electronic warfare, all of these systems have to work together, and they have to work together inside an aircraft that must still fly, maneuver, and survive. That is an enormous engineering challenge. Which brings us back to Germany. Germany's departure from FCAS was not a decision to join GCAP. It was a decision that the original Franco-German industrial structure had become unworkable. But the consequences are larger than Berlin probably intended. It has removed one major European 6th-generation fighter program from the competition. It has increased attention on GCAP, and it has forced countries across Europe to reconsider their options. For Washington, the concern is not that GCAP will suddenly outperform the F-47. There is no evidence to make that claim. The F-47 has not entered service. GCAP has not flown. And comparing their ultimate capabilities today would be speculation. The real issue is choice. If the F-47 is widely available to allies in a configuration that is sufficiently capable, affordable, and politically attractive, American dominance could continue. But if exports are restricted, if costs become too high, or if allies want greater control over technology, GCAP could provide an alternative. And once an alternative exists, America's leverage changes. Consider Canada. Canada has become an observer in GCAP. That does not mean Canada is buying the aircraft. It does not mean Ottawa is abandoning the F-35. But it shows that an important U.S. ally is interested enough to monitor the program from inside its broader ecosystem. Other countries could do the same. Some could become partners, others could become observers, others could eventually become customers. And every country that chooses GCAP represents a slightly different global defense market than the one Washington has become accustomed to. This is not necessarily bad for NATO. In fact, a European sixth-generation aircraft could strengthen NATO if it is designed for interoperability with American systems. GCAP officials have repeatedly emphasized interoperability with U.S. forces. The future does not have to be an American system versus a European system. It could be American and European systems operating together. But interoperability is different from dependence. That distinction could become one of the defining defense questions of the 2030s. Can America's allies operate alongside American forces without being completely dependent on American technology? And can Europe develop its own advanced combat systems without creating incompatible islands of capability? GCAP is an experiment in answering that question. FCAS was supposed to be another. FCAS failed at the political level before the aircraft could demonstrate itself. GCAP now has the opportunity to prove that a different industrial model can survive. But it is far too early to declare victory. GCAP still has to get the engine through ground testing. It has to build the aircraft. It has to fly. It has to integrate weapons. It has to demonstrate stealth and sensor performance. It has to make autonomous systems work. And it has to keep Britain, Italy, and Japan politically aligned for years. That is a huge challenge. The engine milestone is therefore important precisely because it is only one step. The July announcement did not reveal a finished engine. It revealed progress toward the next major test. More than 100 component tests have been completed. Design reviews have been passed. Manufacturing continues. The integrated demonstrator is moving toward ground testing. And that is where the story stands as of August 2026. So the headline should not be that Rolls-Royce already has a sixth-generation engine roaring on a test stand. It doesn't. The more accurate and arguably more significant headline is that GCAP is steadily moving from engineering concepts toward integrated hardware at precisely the moment its main European competitor has lost its fighter. That is the shift. Germany did not leave FCAS because GCAP won. It left because the Franco-German partnership could not resolve its industrial and strategic differences. But the consequence is that GCAP now has far more room to become Europe's primary sixth-generation fighter project. And if the program continues hitting its milestones, that could eventually create a problem for the Pentagon. Not a technical problem, a commercial and strategic one. The United States will still have the F-47, it will still have the F-35, it will still possess enormous advantages in aerospace technology and defense spending. But America's allies may increasingly have another option. They may be able to participate in a sixth-generation program rather than simply purchase one. They may be able to retain more control over technology. They may be able to keep more high-value manufacturing inside their own economies. And they may be able to build a combat system that remains interoperable with America without being completely dependent on Washington. That is what makes Germany's exit from FCAS so important. It is not simply the death of a fighter. It is a change in Europe's industrial map. France is reconsidering its future. Germany is looking for a new path. Britain, Italy, and Japan are pushing forward with GCAP. America is accelerating the F-47. China is advancing its own next-generation aircraft. And the sixth-generation race is becoming a contest not just over aircraft, but over industrial ecosystems and alliance structures. The next major test will therefore not be another political speech. It will be hardware. When the integrated GCAP engine demonstrator eventually starts sustained ground operation, engineers will finally have real data about the complete propulsion architecture. That will tell us much more than artist impressions ever could. It will show whether the consortium's approach to power, propulsion, and thermal management is working. It will expose problems that need to be fixed. And, perhaps most importantly, it will demonstrate whether the political partnership between Britain, Italy, and Japan is successfully producing engineering results. Because that is the lesson of FCAS. A multinational defense program can have enormous funding, it can have world-class companies, it can have ambitious technology, and it can still collapse if the political structure cannot hold. GCAP is now trying to prove the opposite. That political cooperation can produce physical hardware. The engine is not finished. The aircraft is not flown. The program is not guaranteed to succeed, but it is moving. And in sixth-generation fighter development, movement matters. Because once the engines, factories, supply chains, and test facilities begin operating, political momentum starts to build around them. That may be the real significance of summer 2026. Germany's fighter program has effectively collapsed into a search for alternatives. GCAP is consolidating, and the United States is watching a future in which its allies may have more than one path to the sixth generation. The F-47 could still become the most capable fighter in the world. GCAP could still suffer delays. China could surprise everyone, and Europe could yet reorganize its fighter industry again. Nothing is decided, but one thing has changed. Europe's sixth-generation fighter race is no longer a two-program competition. FCAS has lost the aircraft that made it a direct competitor. GCAP is still standing. And now the question is no longer whether Europe can imagine a sixth-generation fighter. The question is who will actually build one. Because in the end, the future of air power will not be decided by the most impressive presentation. It will be decided by engines that run, aircraft that fly, networks that work, weapons that integrate, and governments that can keep paying long enough to finish the job. FCAS could not get there. GCAP is trying. And the next time we hear that Rolls-Royce, IHI, and Avio Aero have started the integrated engine on a test stand, that will be the moment to pay attention. Because at that point, Europe's sixth-generation future will no longer be just a political argument. It will be running in front of us.